Okay, next we're going to need our new textbook. If you haven't got it yet, I'll ask the teacher to pause the video and go to the back of the class and pick up one of the purple textbooks. And there you'll be turning to page 6 and looking at example 1. Example 1, you have a parallelogram, and in there are all different sides. We can represent the sides with vectors. So, for example, let's look at this vector. Vector that goes from A to B. I'll just make sure it's exactly on there. So there's AB. What can I say about vector AB? Well, within the parallelogram, we know that there's a vector that's just like it. It's over here. And you can see that it's exactly like it, and we know that from the properties of a parallelogram that AB equals vector BC. A different vector, it goes from A to D, also has an equivalent vector in it down at the bottom here, vector BC. At this point, I'll ask the teacher to pause the video and give you a chance to look through the vectors, or all the possible vectors in this parallelogram, and list equal partners. Here's a few creative answers. Remember that vectors can be just defined in two directions. So here's another one. BA is equal to CD. It's not equal to DC, but it is equal to CD. Again, I'll ask the teacher to pause the video and verify that you were able to find all of these equivalent vectors as well. Next, we're going to look at vector U here. If we define U as this little blue vector, what happens if I do this? I'm going to clone it, bring it over here, clone it again, bring it over here, and place the two vectors one after each other. Just make sure that the tail of one is at the tip of the other. What this does, it creates a brand new vector that is twice as long as U. Oops. This new vector, this new green one that I've drawn, can be called 2UV, which makes total sense. It's twice as long as U. Because here's one U, and here's another U. So of course if you add U and U, you get 2U. And you get a brand new vector called 2U. So if we can describe this vector 2U, well, how do you think you describe this vector, negative 1/2 U? Well, the first thing we'll notice is the negative tells me that U is in the opposite direction. So I'll clone this one, bring it over here, and I'm going to have to flip it twice. Flip it left, and flip it up and down, and that will get me at least negative U. But I need a vector that is half as long. So I'm just going to estimate here and draw one that starts here and goes about half as long as that one. I'll just move this off to the side, and that can be defined as negative 1/2 u. The negative tells me it's in the opposite direction to the original u vector, and the half tells me that it's half as long.